Hello, I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 27, for the week of July 8th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, July 8th, the moon is big and bright in our morning sky, rising an hour after darkness settles. As the week progresses, the moon rises later each night and dims slightly. This is a good week for evening observation, and at least until moonrise, which looks pretty good in a telescope or binoculars. Early on July 11th, the moon passes just south of the planet Mars, and that bright object in your pre-dawn sky is the planet Venus. By dawn, these 4 planets are stretched across the sky: Jupiter, Saturn, Mars, and Venus. What's not to like? Jupiter comes to opposition on July 14th, which means several things. We are between it and the sun. It rises at sunset, and it sets at sunrise. It's highest in the sky around midnight or 1 a.m. for those with daylight savings time, and it is closest to us. It officially passes from the morning sky into our evening sky. It is in the southern sky at minus 21 degrees declination. So from 35 degrees north latitude, let's do the math. The highest it gets in our sky is 90 minus 35 equals 55. That's the declination at our southern horizon, is minus 55. Minus 55 plus 21 is 34 degrees high in the sky, which is as good as it gets. So it does not really get high in the sky for those in the northern hemisphere, but with a steady atmosphere, it does look really good. Jupiter, now in our evening sky, will be observed more frequently than before when it was in the morning sky. And the planet Saturn rises about 40 minutes later. It will reach opposition on July 20th, and we will discuss Saturn more next week. But back to Jupiter, our largest planet, 10 times larger than the Earth and 10 times smaller than the Sun. Through binoculars, you can usually see the 4 brightest moons of Jupiter. In binoculars or a small telescope, the bands, or stripes, can be seen on the face of the planet. When we show this planet at public star parties, some people think those are rings, but those are stripes on the planet. Put the telescope on it and crank up the magnification. The moons may take on the shape of a disk, and some amateur astronomers can tell one moon from another. I can't do that, but some can. Wow. Jupiter's moons do vary in size, color, and orbit. And if you want to become one of those rare amateur astronomers, then practice and observe keenly. Jupiter rotates once every 10 hours. So the shape is not exactly round. It's about 10% wider at the equator than through the poles. The great red spot is visible for only a few hours on each rotation when it is pointed towards Earth. Look very carefully at the planet and see the swirls between the stripes. See a shadow cast by Jupiter. A few months ago, we tried several times to see the shadow cast by the light of the planet Venus. At that time, Venus shone with a magnitude of minus 4.5. Now let's try to see a shadow cast by the light of the planet Jupiter, magnitude minus 2.7, about 5 times dimmer. By this weekend and into next week, the moon will be out of the sky when Jupiter is at its highest point. This is one way to do it. Go out and get used to the dark, and that will take several minutes. With your back to Jupiter, hold a sheet of white blank paper in front of your face and see if you can see the shadow of your head outlined on the paper. It will be faint but distinct. If that does not work, try it this way. Put Jupiter to your left or right. Hold up a sheet of white paper and run your hand and open fingers so that they are between Jupiter and the paper. Look for the shadow of your hand this way. Will you be able to see the International Space Station this week? If you live north of about 38 degrees, you have the ISS in your morning sky 2 or 3 times per night in most cases. By the end of the week, you'll begin picking it up also in the evening. Detroit, Rhode Island, Canada, Ireland, France, Russia, that's you. AM, early and often. Between about 38 degrees north and minus 20 degrees, you've got nothing. Until the end of the week when you begin to pick it up in the evening with some morning passes. Be patient. It gets better next week. South of 20 degrees south, it will be in your evening sky for the first half of the week, and then not at all. To determine where the International Space Station will be in your sky, go to the website heavens-above.com and enter your location, then click on International Space Station. Amateur Astronomy Observatories. Sooner or later, most astronomers will want an observatory to not only house the equipment, but to observe from. But before we get to the observatories, let's step back a bit and talk about something to house the equipment. I've seen amateur astronomers build a small shed or use a tough shed or something similar to house their telescope. It needs no electricity and can be placed almost anywhere. Then, when it is time for observation, open the shed, wheel out the telescope, and get to work. This is much easier than carrying it out from your bedroom, as I used to do, or the garage, as many do. The shelter can also be used as a windbreak. Sometimes an individual will buy a plot of land out in the rural area with less light pollution, or use the site owned by the local astronomy club and build a shed there to house the instruments. This makes observing easier for the astronomer, as they merely have to drive to the site, roll out the telescope, and get to work. What would make this even more convenient is when you can observe from that shed with the telescope still in place, aligned to the North or South Pole and ready to go. That is called an observatory. The two types of astronomical observatories that I know of, one type has a dome with an opening known as the shutter running down the side, and the dome rotates so that you can see different parts of the sky. The second is a roll-off roof observatory where the whole roof rolls aside, revealing the vast sky overhead. Domes first. For a refractor telescope or a Schmidt-Cassegrain, the telescope is placed on a pier, usually separate from the floor of the observatory, so that the vibrations of the floor and rotating dome do not shake the telescope mount. Almost no one builds the dome themselves. You can buy domes of 6 to 15 feet in diameter. That's 2 to 5 meters across. The dome and the related hardware to move it and open and close the shutter is then placed onto a topless building, usually a square building made of masonry or wood. Sometimes a rectangular building is built and half or more of it is not under the dome but has a fixed roof. And that area is the warming room or the computer room used for imaging. Domes can also be placed on garages, over bedrooms or dens, almost anywhere. I've often heard it said, don't build too small of an observatory. That's a good point. Decide beforehand what the largest instrument you would ever have in there and how many observers would be using the telescope at the same time. My example, my 16-foot by 10-foot, that's 5 meters by 3 meters, roll-off roof observatory, which I'll discuss next week, was large enough to house 2 instruments and me, and could handle 3 or 4 people in the rare cases where I had visitors. A few times we had 10 or more people, and for those star parties I set up an additional telescope or 2 on the ground outside the observatory, and guests shuffled between the observatory telescope and those telescopes outside the observatory. A dome observatory limits how much sky you can see. Some people miss that and some do not. Once you walk into the observatory, the only sky you can see is through the open shutter. You will miss meteors, satellites, northern or southern lights, and anything else going on outside the dome. The advantages of the dome is that it does block wind and light, and it can retain some heat and offers security from outdoor critters and people. Go in, lock the door, you are safe. There is a disadvantage if you're using a reflector or a Dobsonian mount, as the walls of the observatory will block much of the sky. And there's very little wiggle room in a domed observatory to maneuver around a large Dobsonian reflector. And for what it's worth, it looks like an observatory. When you say, I have an observatory, the dome is no mystery for anyone. Like, wow, there it is, cool, an observatory. That's a dome observatory. The other type is the roll-off roof observatory, where the floors and sides remain in place and the roof slides on rails out of the way so that you can see the sky. These are typically easier to build and less expensive than a dome. With the roof off, you have access to the full sky with limited protection from the wind and lights, and you still have security. Where does the roof go when it's party time in the observatory? It is on wheels, and it is slid on its tracks to sit over a usually wood-built frame of the same height as the observatory, and that holds the roof when it is not covering the observatory. The roll-off roof generally stays at the same level as it is rolled off, sometimes with a winch or pulleys. When done, you shove the roof back into place. The roll-off roof observatory I had in Colfax had often been mistaken by guests, UPS drivers especially, as a chicken coop, hot tub, or a grower's room. It simply does not look like an observatory. When we marketed and sold the house last year, we mentioned it was an observatory, but that it could have other uses too. Ideally, if you live in the northern hemisphere, the roof should slide off to the north, allowing more free southern sky. Make sure that the roof will not blow off, so not only is it on wheels, but should have some type of hooks to hold it in place when both opened and closed. You don't want to have to go to your neighbor's house to retrieve your roof. I'd recommend an elevated floor on posts and piers. This makes it easier to level the floor and keeps out at least some of the critters. You can also have room under the floor to run electricity if you wish. You can still use a pier to hold the telescope if you want it permanently mounted, and run that pier through the floor and into the ground below. Some counties and cities allow you to build up to a certain number of square feet before you need to get a permit, which is permission from the government to do something on your own land. In some areas, anything over 144 square feet needs a permit, or 200 square feet might be the trigger point. There are many books, magazine articles, and YouTube videos on how to build an observatory. There is no need here to reinvent the wheel. What if you have a Dobsonian reflector or a low-sitting telescope? Is it possible to build an observatory with low walls so that you can observe near the horizon? In Colfax, California, I had that problem. And so in the early 1990s, I designed and built an observatory to solve it. I'll discuss that next week. Comet NEOWISE stuck its head out from behind the sun and smiled at us. After spending a week in the SOHO camera, Comet 2020 F3 NEOWISE emerged into our morning northern sky. It was picked up as early as July 1st by Alpo comet recorder Carl Hergenrother and by others, and it appeared bright, with a tail and a magnitude about 1 seen against the twilight sky. Most of us were seeing it with the unaided eye within a few days as it crept into darker skies. Comet NEOWISE remains in our morning sky as it passes north of the sun until it officially enters our evening sky on July 14th. If you live far enough north, so far north that the sun takes a long time to get a decent distance below the horizon for the sky to darken, you are in luck. You might be able to pick up the comet in the evening sky as early as July 10th in twilight. But at that time, it will still be more easily visible in the morning sky. Meanwhile, Comet NEOWISE, still visible in the morning sky, reaches a maximum height above the northeast horizon at about July 10th. Then it retreats back in towards the horizon. By then, it will be passing off from the morning sky to the evening sky on July 14th. There will be a few days around that time when, if you live far north enough, you'll be able to see it both in your evening sky and your morning sky. See if you can see it with the unaided eye. Finding it first in binoculars makes this easier. As the days go on, it is expected to dim. Comet 2019 U6 Lemon is at magnitude 7 in our evening sky, headed north and east. Meanwhile, Comet Pan-STARRS 2017 T2 remains at magnitude 9 and is headed slowly south. They will meet in early August. Two comets are best seen from the southern hemisphere, and both are plotted on Podcast 27, Map 3, designed for the southern hemisphere. Having said that, both make an appearance to northern hemisphere observers too. The first comet is Comet 2P Encke with a short orbital period of 3.3 years. This appearance is not well placed as it appears close to the sun as seen from the Earth. Then, as it gets into the darker skies, it dims a bit. The second is Comet 88P Howell. It comes by every 5.5 years. It is presently about magnitude 11 and should brighten to magnitude 9 by September. Positions for all 5 of these comets can be found on my website, Podcast 27, Comet Positions. Maps for these comets can also be found on my website. The evening sky maps for the northern hemisphere is Podcast 27, map number 1. It shows these comets in the evening sky. I made another map for those in the southern hemisphere, and that is Podcast 27, Map 3, the Southern Hemisphere Comets Howell and Encke. Again, you can get that from my website. Our challenge for this week is to learn a new constellation, and that is the constellation Scorpius. This one looks like its namesake. It's Scorpius the Scorpion. It is identified on podcast 27, map 1, and map 2. The constellation Scorpius begins with 2 claws on the western end. The middle star, Delta, identified on podcast 27, map 2, is the one to watch. It does brighten from time to time and remains bright for several months. From the claws of the Scorpion, we head east and south to the bright star Antares. This star is a red supergiant which varies in both size and brightness. If it were placed in the position of our Sun, we and the next outer planet Mars would be inside of it. So it is a very huge star. From Antares, we continue south and then east and then back north again to the stinger of the Scorpion. So here we have the constellation Scorpius. Get to know it, and once you learn it, you will never forget it. With binoculars, sweep around the star Antares under dark skies. You'll notice some non-uniformity here. There are clouds of gas and dust in this area, especially north of this star. To the west is a small fuzzy ball. It is the globular cluster M4. It is relatively close for a globular cluster, only about 7,000 light years away. Even in binoculars, you might note that some of the stars are not distributed uniformly. There is a line of brighter stars running north-south down the center of this cluster. In a telescope, you can see many more stars in M4, and the north-south line of stars should be obvious. This is one of the looser and closer globular clusters, so this provides a good opportunity to study a globular up close. Do you care to count the stars? Midway between Antares and M4, and to the north a bit, is another globular cluster, number NGC 6144. It's about magnitude 9. Now for fun with the marathon. The most common Messier marathon is done in late March when, from certain latitudes, 110 of the 110 galaxies, clusters, and nebula, cataloged by Charles Messier, can be seen in one night. This is known as the Messier Marathon. But the Messier Marathon can be done any night of the year with various results. With a new moon coming on the weekend of July 18th, what can be seen? About 94 to 98 of the 110 objects can be observed in one night. If it was me, I would begin with M68, 104, and M83, then head north for the Leo and Virgo galaxies before they set. Then up to the Big Dipper for more galaxies, then hit the summer Milky Way, which would be high in the sky. You will be kept very busy, and after 2 hours, as you pick up the Andromeda galaxy in the northeast, you will have seen about 88 objects. As more objects rise, you hit those, and you will end up your morning with the 3 open Auriga clusters, M38, 36, and 37, M1, and M35. You have been listening to Looking Up with Don, podcast episode number 27 for July 8, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky. We'll continue observations of Comet NEOWISE, learn yet another constellation, and I'll talk about the observatory that I built to handle large reflectors searching under the horizon. Thank you for listening. See the sky this week. I'll see you next week.